This is a radio receiver, Redcon brand. There's many different kinds of brands. What we've got here is lots of output pins. So the signal from your transmitter comes in, your command roll or pitch or whatever, picked up by the antenna. Very fragile, so we'll move them out nice and straight, gently. And the signal is sent out from these output pins to a device like a servo, which is an electric motor. And servos will be in another video. It's on the 2.4 gigahertz band. So your transmitter, didn't mention this in the last video, your transmitter is capable of having a certain number of different models in it. And I can change what models are on the transmitter. I can have a helicopter on model 1, I can have my drone on model 2, I can have my fixed wing aircraft on model 3, I can have my UAV challenge competition aircraft on model 4. The DX8 has up to 30 different models. Some of our cheaper transmitters have, I think it's 30, our cheaper transmitters have up to 10 different models. And the whole beauty of the system is that this model on this transmitter can only talk to this receiver, and that's on the process called binding or pairing. If I inadvertently pick up the wrong transmitter, power up the receiver, it won't talk. They won't talk to each other. It's a safety feature. Okay, your aircraft won't take off and perform erratically and crash into someone or something. I have to have the correct model on the correct transmitter. At the moment I've got model number 12. I haven't named this, it's just called Acro, but it's an aircraft. And that's been paired to this receiver. I'll show you the process of pairing now. Incidentally, this little additional component here is called a satellite receiver. This is the main receiver. You don't have to have a satellite. I can unplug that. What this enables me to do is to have my receiver mounted on my aircraft. Remember we talked about the most gain on an antenna in the transmitter video is perpendicular to the antenna. That's where the most gain comes out, perpendicular. 90 degrees to it, wherever that is. There's little gain at the top, that's why we don't point our antenna at the aircraft. Likewise, the most gain is perpendicular to the receiver antenna. So I'll mount that in the aircraft one way, and I'll mount the receiver in the aircraft one way, and I'll mount the satellite at a different orientation in a different part of the aircraft. I would not mount them side by side like that, because if there's a piece of carbon spar in my aircraft, some other piece of metal, it might possibly block the signal. So I mount them perpendicular, because the most gain is, I mount these perpendicular to each other because the most gain is perpendicular to the antenna, and apart. So at any stage, one of them will always be facing or open or receptive to the signal in the most optimal way. Okay, let's bind these together. So I need a bind plug. Bind plug simply shorts, that's just a piece of wire there that shorts out the two outside pins. There's 3 pins there, 1, 2, 3, and that's a piece of wire that shorts the 2 outside ones. If you ever don't have a bind plug, you can get a piece of wire to short out the 2 outside pins. If I go to my bind plug now, let's have a look. I'll see if I can focus on that. It says at the top there, it says bind and data. I put the bind plug in there. Basically that's shorting the outside 2 pins and telling the circuitry inside that I'm going into bind mode. I make sure my transmitter is off. There's my bind switch there, which I'm going to hold down in the process of binding. I'm going to apply power to the receiver. Now the outside pins, they're in 3s all the time. And the outside pins are always negative. Outside pins are negative. And then the middle pin is power, which is red, and the inner pins are data. So I apply power. There's my earth, the black. I need just a 4-cell NiCad nickel metal hydro NIMH battery. This is NiCad. Each cell is 1.2 volts. More about batteries later. 4.8 volts. Anything more than 5 volts, this little cheapo receiver will be fried. So don't put any more than 5 volts on it. So 4.8 volts is fine. I can put that on any pin. I can supply power. And the flashing indicates it's in bind mode. Okay, you can see it flashing there. Now, transmitter's off. Hold the button down. Switch on. And it should say it's in bind mode, which it is. I get solid state there. The LEDs, which means it's bound. Let go. And that should be bound. Let's check it. Disconnect power. Take out my bind plug. If I leave the bind plug in, it'll just go back into bind mode. Okay, I'll plug a servo in. This servo I'm going to put on my aileron channel. Okay, and outside pins, that's aileron there. Outside pins are negative. Okay, there's a servo. Once again, it's a little electric motor. Apply power on any pin. Solid state. There's the servo. And there's my roll. Hold roll. Okay, let's get this sorted. Left roll, right roll. And that would push a control rod, which would be connected to my control surface, which would move it. Okay, so it's bound. Disconnect power. And we know we're good. That's the process of binding. And more on servos and batteries coming up. And that's about all we need to know for the radio receiver. Just make sure you mount it correctly in the right orient, anywhere, but just at 90 degrees to the satellite. Okay, piece of Velcro on the back, and don't hide it behind any carbon or metal engines or whatever.